let's talk about a way you can use your graphing calculator to check your work from going from x and y components to r and theta and vice versa. First, let's talk about going from x and y components to r and theta. Here I've written two example problems, one for pre-calculus with polar coordinates and one for physics with vectors, that could use this way of checking your work by using a graphing calculator. Press second and press a button that has a main text saying apps in purple and the blue text above it saying angle. Choose option 5 to figure out the positive radius or the magnitude from the x and y components. Enter in the x and y components and separate them by a comma. Press enter. Now we have easily checked the approximate magnitude of the physics problem. However, for the pre-calculus problem, we had given an exact value for our answer. How will we check it? Enter in 6 square roots of 5. It yields the same approximate value as the calculator gave earlier. What about the polar coordinates with a negative radius? These ones here. The radius would have the same absolute value, but the only thing that could change would be the minus sign. And indeed, the absolute value of the negative 6 square root of 5 is positive 6 square root of 5, and we've already checked that radius. Okay, we checked the radius, but what about the angle? Go to mode and make sure that if the problem is in radians, you are in radians. And if it is in degrees, you are in degrees. Now these problems I'm using right here are in degrees, and my calculator now is in degrees, and so I'm good. Press second angle again. Choose option 6 to figure out the angle. Enter in the x and y components and separate them by a comma. Press enter. Now it gives an angle. Now for the physics problem, we want the angle to be between 0 degrees and 360 degrees, but the angle the calculator gave was negative. So add 360 to this value. Either way, the angle would end up at the same place. The new answer the calculator gave was the same we had for the physics problem, so we checked the angle for the physics problem. We have also checked the angles for the first two answers for the pre-calculus problem as well. The first answer the calculator gave was about negative 26.6 degrees, and the second angle the calculator gave was about 333.4 degrees, and our answers here have those angles. How will we check the angles for the polar coordinates with a negative radius? Well, it would mean to add 180 degrees and then to add or subtract as many 360 degrees as you want. So add 180 to the original angle the calculator spat out. Now to check this angle, subtract 360. And so we have checked all the angles mentioned in these problems, and so we have finished checking our work. So now we showed how to check your work by using a graphing calculator for going from x and y components to r and theta. Now let's talk about how to check your work by using a graphing calculator for going the opposite way. If you have not already done this, go to mode and make sure that if the problem is in radians, you are in radians. And if it is in degrees, you are in degrees. Go to second angle. Choose option 7 to figure out the x component. Enter in r, enter in a comma, enter in theta, and press enter. We can easily tell right now that the x component for this answer of the physics problem is correct. However, how would we check the x component of the answer for the pre-calculus problem? Type in negative 5 square root of 3 over 2. It has the same approximate value as the answer the calculator spat out, so we check the x component of the pre-calculus problem. To check the y's, go again to second angle. Choose option 8. Enter in r, enter in a comma, and enter in theta. We can easily tell right now that the y component for the answer for the physics problem is correct. However, how will we check the y component of the answer for the pre-calculus problem? Type in negative 5 halves. It has the same value as the answer the calculator spat out, so we check the y coordinate of the pre-calculus problem.
Here's the link to the playlist which this video is a part of. It includes other similar videos about how to use your graphing calculator to check your work, such as how to check adding vectors when you're given them in the magnitude and direction format and you want to answer in the magnitude and direction format.